This is Radio TV Phono Nut, and what we have here is a cute little Symphonic kitty record player from 1956. This one is in unusually good cosmetic shape. Most of these kitty record players are totally ragged out. Well, I overhauled the amplifier and the drive mechanism. All I need to do to the drive mechanism is replace the idler wheel to get rid of that thumping sound, but for right now it'll do. This uses the old flat style crystal cartridge with a 2mm all-speed spike needle in it. Tracks at about 12.5 grams. Let's see what it does. Well, it works and it has plenty of output, but it sounds a little bit on the distorted side. I'm sure the needle is not in the best shape. Now, what I want to do is replace this cartridge with something more modern. And why would I want to do that? Well, number one, because this old cartridge is not in the best of shape. And number two, it's very non-stereo compliant. Back in 1956, there were no stereo records. They didn't come along until '58. And these old cartridges have virtually no vertical compliance, which means if I tried to play a stereo record on this, it would damage the record if it would even play it at all without skipping. So we want to install something more modern that tracks lighter and is stereo compliant, and something that will play any kind of record you want. And I have a Fan Steel P226 cartridge ordered from the VM site that has a flip over needle, one side for LP, one side for 78, but for now I'm going to install this crappy Crosley cartridge in there just for demonstration until the other cartridge gets here. And I mean, these really are crappy. Well, let me back up. These kind of cartridges here are okay if you order the genuine Chuo Denshi product that's made in Japan. But the crappy knockoffs from China are really not that great. The pins are often loose and you have to glue them in place before you can even slide the connectors over them. I mean, they're just all around crappy made, but hopefully this one will work good enough for a test until we get our desired cartridge in the mail. And the best way to do this is just pull the motor board out, flip it upside down, and have the tone arm in this position. That makes everything a lot easier to get to. Okay, here we are with a little cheapy red cartridge in place. I just simply wire the left and right channels together for mono, and it works and sounds good, but here's the problem. That's wide open. That's wide open. We don't want to get any more of that song coupled with what I think we got earlier. I did use this earlier, didn't I? I think so. It's been more than 5 minutes since I did the first part of this video, so I really don't remember. But at any rate, it really don't matter what song we play. Let's get back to the business at hand. Why is it so much softer with this cartridge than it was the old cartridge? Well, let me explain that. The original cartridge puts out 3 volts output. This cartridge here puts out maybe a half a volt output. Actually, the specs on it are 0.33 volts, I think. And what they do here with the original cartridge, they're driving the output tube directly. There's no preamp stage. Well, this cartridge is obviously not hot enough to drive the output tube directly to its full potential, so how do we get around that problem? We'll have to construct a preamp stage to add to the original design here. Here's our amplifier chassis. As you can see, it's nice and roomy and not much to the original design. I've already taken the liberty of mounting a separate octal tube socket for the 6SQ7 driver tube that we're going to use. It fit right in the existing hole where the old filter capacitor was. And since modern components are so much smaller than the original parts, I was able to mount the filter capacitors on this terminal strip to the underside of the chassis, and that left this hole right open for a tube socket. Now the question remains, what kind of preamp tube do I need to use for one of these? Well, there's a couple of things to consider when making your decision. You'll need some type of triode tube. The most common types that I use in this application is either a 6AV6, 12AV6, 6SQ7, or 12SQ7, which is a triode and a dual diode. It's commonly used as a first audio and detector tube in a lot of 5-tube radios. Well, in this case, all we'll be using is the triode section, and we won't be worried about the dual diode section. It'll be unused. Now let's determine what would be the best tube to use for our particular application. Okay, here's our typical filament circuit of a one-tube Wonder phonograph. We have our 120 volts AC coming in, going through the 90 volt winding on the phonograph motor, wired in series with a 25L6 tube. It could also be a 25C5 or 25EH5 miniature version. But at any rate, it's a 25 volt filament, 300 milliampere. Add the 90 volt motor to the 25 volt tube, and it gives us 115 volts, which is pretty close to what the line voltage was back in the day. In today's world, it usually runs between 120 and 125 volts. Now, one of the rules of a series circuit is everything in the line must have the exact same current rating. In other words, everything has to be 300 milliampere. So we need to keep that in mind when selecting a tube for the preamp stage. Number one, it needs to be a triode tube. The filament voltage needs to be low enough where it won't upset the total voltage added up here too much. And the current draw on the filament needs to be 300 milliampere. Well, I generally use either a 6AV6 or a 6SQ7, depending on whether or not I need a miniature tube or an octal tube, because that particular tube has a 6 volt filament, 300 milliampere. We couldn't put a 150 milliampere tube in here. That would disturb the whole shebang and mess things up. Here's our new drawing: 90 volt motor, 25L6, and our 6SQ7, and that adds up to 121 volts, which is close enough to the line voltage. Even if your line voltage is a little low, it won't really make any difference. It'll just take a few extra seconds to warm up, but it will work just fine. So what you need to remember is pick a preamp tube that's a triode. Make sure the filament is low enough that it won't upset the total voltage here when it's added up. It needs to be in range that the 120 volt AC input will be sufficient, and your preamp tube should have the same current draw on the filament as what the other tube has. Otherwise, it will screw up the whole works. Okay, we've now completed phase 1, wiring the filament of the new tube. Originally, our motor came in to pin 2 of the 25L6 output tube, which is one end of the tube filament, or heater, whatever you want to call it. And then it came out of pin 7 and ran over here to circuit ground, which ties to one end of the switch. Right here is pin 8, which is our cathode, and originally the capacitor and resistor was grounded over here to pin 7, which of course formerly went to ground. Well, I moved our ground connection for this capacitor and this resistor to pin 1, which is an unused pin, and then we ran a lead from pin 7 of the 25L6 over to pin 7 of the 6SQ7, which is one end of the heater pin, and then pin 8, which is the other heater pin. We ran that over to circuit ground here, and then we ran a wire from our new output tube ground, which is now pin 1, over here to circuit ground. So that takes care of the filament part of it. Now the next thing we need to do is prepare the audio output tube for the addition of the driver tube here, and that won't be hard to do. In fact, I will show you a schematic of this, and it's one tube configuration, and it will be very easy for me to show you what needs to be done. Okay, here's our diagram, crudely drawn out. Our pickup cartridge is grounded to the chassis. That symbol designates chassis ground. This symbol designates circuit ground. Plus end of the cartridge goes into one end of the 500K volume control. Other end of volume control connects to circuit ground. We have a 33K ohm resistor, which is not always present in these. It goes from the center of the volume control to pin 5 of the 25L6 tube, which is our control grid. Pin 8 is the cathode, 150 ohm resistor between there and ground, paralleled by a 22 microfarad 50 volt cap, with this end here being plus. Pin 4 is our screen grid. Pin 3 is our plate that goes over to the output transformer. And then of course this is the speaker. Now this capacitor here is our chassis isolation cap. It's a 0.047 microfarad, and you should really use a modern AC safety capacitor in that place. You can see one end connects to chassis, one end connects to circuit ground. And here's our power supply. We have 120 volts AC going in through our motor field coil, then through our 25L6 over here to ground. And then coming down from here, we have a 47 ohm surge current limiting resistor, our 1N4007 diode, and a 150 ohm resistor here. Now keep in mind, originally this had a selenium rectifier, and when it had that, this resistor was not present. I added this just as a little extra margin of safety. Okay, so coming off of this 150 ohm resistor, we have our 50 microfarad capacitor, and our 8.2K ohm resistor, and a 30 microfarad capacitor. Now this 0.1 off of this first capacitor goes up to 0.1 on the output transformer and comes around to your plate. And our point number 2 on the last capacitor after the dropping resistor goes over here to the screen grid. Now what we've done so far is we've broken this connection, and we've added a 6SQ7 in the filament line here, pins 7 and 8. Now we need to prepare this tube for the preceding preamp stage that will soon be in front. And then you will need to attach a 0.01 microfarad capacitor to pin 5. And then the other end of the capacitor will go back to the plate of the 6SQ7 audio tube, but more of that in a minute. Some models do not have this 22 microfarad cathode bypass cap. If your model doesn't have it, then you need to add it. It's not a critical value. 22, 33, 47, any value in that range will work. And 25 to 50 volts working voltage for your cap will be plenty enough. And make sure that your positive terminal of the capacitor is connected to the tube cathode, pin 8. And that's the terminal that does not have the band on it. The terminal that has the band on it designates the negative terminal. Okay, we now have our output tube circuit prepped. We have our 470K ohm resistor, one end connected to pin 5, which is the control grid of the output tube, the other end connected to ground. Here's our 0.01 microfarad capacitor, also connected to one end connected to pin 5 of the 25L6, and the other end goes back to pin 6 of the 6SQ7, which is the plate. Now, this resistor here in the power supply that was formerly in 8.2 k ohm resistor. Everything would stay where I want it to stay. This guy right here that you see in the picture here, that was really a little bit too much for a two tube record player. Usually in that application, the resistor is anywhere between 1,000 and a 3,300 ohm. I went with a 1,500 ohm resistor in that application, and now we'll run a resistor. From pin 4, which is our screen grid of the 25L6, back over here to pin 6, which is our plate of the 6SQ7. That will provide plate voltage for the tube. And it's not really critical, but something along the lines of 470K should work. There again, I've seen values from 330K all the way up to a meg ohm, depending on the manufacturer and how they wanted to design it, but we'll go with a 470K. And there's our 470K ohm resistor in place. Okay, that completes the output tube stage, except for one thing, a tone compensation capacitor, and I'll talk about that more once we're almost to the finishing stages of this. And we have the plate side of the 6SQ7 complete. So now all we have to worry about with the 6SQ7 is our cathode and our control grid connection. And our cathode connection, which is pin, let's look at the tube manual here. Our cathode is pin 3 of the 6SQ7. We'll just tie that to circuit ground. Okay, we have our cathode, pin 3, grounded. Now let's concentrate on pin 2, which is our control grid. Let's run about a 6.8 meg ohm resistor between pin 2 and circuit ground. Okay, we have our 6.8 meg resistor from pin 2, control grid to ground, and we have our 0.01 microfarad capacitor between the center terminal of the volume control and pin 2, the control grid. Alright, we're about ready to fire this up and see if it smokes or works or does nothing at all. Yeah, let it warm up here. Oh, well, that don't sound too great, does it? Sounds like we got some oscillation going on here. Could I have possibly done something wrong or forgot to have added something? Okay, one simple ground connection. Pin 1 of the 6SQ7 is the actual shield pin for the middle envelope. Grounding that to the chassis takes care of the squealing, so we will make that connection more permanent, and hopefully that'll take care of our issue. Well, that took care of the noise, but it's still not very loud, so what's the deal here? Well, I believe this 6SQ7 is bad, even though it tested good. Gotta hold this a second while I tap on it. Let me put the camera down. Just listen. Now it got softer. Let's go find another 6SQ7. Okay, another 6SQ7 took care of the problem. It's still a little weak, but I think that's because we're using a low output cartridge. I think when I get the higher output P226 in here, it'll be a little louder. Now we'll discuss the tone compensation cap that I mentioned earlier. As you can hear, that's a little bit too shrill sounding. So what do we do about that? What we'll do is connect a capacitor across the audio output transformer primary winding, and the value of the capacitor will depend on your particular record player and your particular tonal taste in music. We'll try a 0.01 first and see how that sounds, but it'll generally range from, say, probably a .01, .047. You just have to use what suits your ears best. Okay, I went with a .047 microfarad, and I actually decided to connect it between the plate of the output tube and ground, and that cut some of the shrill sound off. It doesn't sound quite as bad now. Okay, I swapped the 0.3 volt Crosley cartridge for a 1.3 volt 89T, which is something I'm trying to get away from, but that seems to be the trouble. This particular design likes the high output cartridge, and it's basically the same circuit that some of the old tube type Caliphone record players use. It has an 89T cartridge, so it's just the way it's going to have to be. Okay, I tweaked the values of a couple of resistors, and now I've got all kinds of gain. I raised the 6.8 megohm resistor on the grid of the 6SQ7 up to a 10 megohm, and then the screen grid dropping resistor, the plate load resistor for the 6SQ7, started out with a 470, then I went down to what I believe a 220K. Now I'm down to 100K, give us a little more B+. And with the 89T PowerPoint cartridge, it's really too hot now for that cartridge. See how little I'm having to turn this volume control? So yeah, this should easily accommodate a half a volt cartridge now. Okay, we're back to the 0.3 volt Crosley cartridge, and it has plenty of gain now. Okay, I finally have it about to where I want it to be. Of course, this is not going to have booming bass with a little 4-inch speaker, but it sounds pretty good. I'll draw up a schematic and show you the finished product. Okay, here's the finished product. Start off with our chassis isolation cap of .047, which is an AC rated safety cap. One end connects directly to the chassis, the other end connects to circuit ground. And we look up here, we have our cartridge. One end connects to chassis ground, other end of the cartridge connects to a 470k ohm resistor, other end of the resistor connects to the one end of the 500k ohm volume control, other end of volume control connects to circuit ground, and we have a .01 microfarad coupling capacitor going to pin 2 of the 6SQ7, that's control grid. Then we have a 10 megohm resistor going from the control grid pin 2 to circuit ground. Cathode of the 6SQ7 goes to circuit ground. Then our plate, which is pin 6, goes out through here, connects to one end of a .01 microfarad cap, 600 volt. Other end of the cap connects to pin 5 of the 25L6, which is the control grid. We also have a 100k ohm resistor connected from the plate of the 6SQ7 back down here to pin 4, which is the screen grid of the 25L6. Our cathode of the 25L6, which is pin 8, connects to a 150 ohm 1 watt resistor to ground. with a 22 microfarad 50 volt cap in parallel with that resistor. And we have our plate, pin 3, that comes around and connects to one side of the primary winding on the audio output transformer. And we have our tone compensation capacitor, 0.047 microfarad, 600 volt, connected from plate to circuit ground. And like I said, you can play with that value to get the sound that you want. Okay. And our screen grid comes down to 0.2, and our audio output transformer primary to 0.1, which brings us down to our power supply. We have the hot side of the AC line coming in. One end connects to the motor winding. Other end of the motor line winding connects to the 25L6 filament, as you can see, pins 2 and 7. And that comes down and connects to our 6SQ7 filament, pins 7 and 8, and then it goes to circuit ground here. Also coming off of our hot side of the line, we come down to this 47 ohm 2 watt surge current limiting resistor that I just put there because I wanted to. And we go to our 1N4007 diode. And take note, this is the cathode band right here. That's the silver band on the diode. Goes to 150 ohm 2 watt, more surge current limiting. And we connect to a 47 microfarad 200 volt capacitor. This is the plus end. Other end goes to circuit ground. And a 1500 ohm 2 watt resistor here, followed by a 33 microfarad 200 volt capacitor here. And again, this is the plus end. This is 0.1 on the first filter capacitor, which goes up and connects to your audio output transformer primary. This is 0.2, which goes up and connects to your screen grid of your audio output tube, which also has this resistor connected to it that feeds plate voltage to the 6SQ7. Here's our neutral side of the AC line that goes down to the switch. And the other side of the switch connects to circuit ground. So there you have it.
And now someone else is getting all your best. These boots are made for walking.
And it sounds a little bit better with the record player back in the case.
I'm gonna walk all over you.
Get that off of there for the copyright police have a hissy.
I'm thinking of crime. A man named Lois said, boy, you better swing low. If you end up in jail, you know your blood will be cold.
And it even plays a more modern stereo record that without skipping all over the place. So that was our objective. Okay, really the only thing left to do to this is when the P226 cartridge shows up with the flip over needle, I'll replace it. Of course, if you have one of these and have no intentions of ever playing a 78 RPM record, then you can go with this kind of cartridge, as long as, like I said earlier, you get the genuine Chuo Denchi version with the metal stylus, not the cheap $3 eBay cartridge from China. But me personally, I like to play 78s, and I don't like having to physically swap needles out, so I will be adding a cartridge with a flip stylus on it.
Ask what answer can I find? I ain't saying I'm a genius. 2 + 2 is on my mind. 2 + 2 is on my mind. Well, I knew a guy in high school, just an average friendly guy, and he had himself a girlfriend, and you made them say goodbye.
Here we are with an LP. Well, that ought to about do it. Now, in the future, I'll make another video because there is a solid state preamp that we can make for models that may not have enough room on the chassis to add an extra tube socket, etc., etc. But hope you got something out of all of this mess. And with the cartridges not being made like they used to, we're going to have to learn how to do stuff like this if we're going to keep these old things going.